Hello, welcome to 1316. In this video, we're going to go ahead and start talking about some definitions. And before each section, I'm going to go over some definitions. Now, I'll probably remind you about these definitions as we go along, but these are important as we go along. So there are quite a bit for this first section. And trigonometry has a lot to do with angles and relationships for triangles and all that type of stuff. But before we get there, we have to build up to an angle. So there's something called a ray. A ray is a point on a line together with all points of the line on one side of that point. In other words, you start here and then go in one direction forever and ever. So that would be a ray. Now, an angle is a union of two rays with a common endpoint. In other words, if I took a second ray starting here and going in that direction, notice that they have the same endpoint. That means that the angle, will be that right there. Now, there is something called the vertex. The vertex is the actual common endpoint of an angle. So in this situation, the vertex is right there. Okay, now we're going to talk about initial side and terminal side. And in this case, it's not going to be all that clear because I haven't really defined a coordinate system. But you can say that we can start here and go up towards the blue this way, or we can start at the blue and go up towards the green that way. Either way works. But the initial side is just the fixed ray of an angle, and the terminal side is the rotated ray of an angle. In other words, if you started with the green and you rotate down to the blue, that means that the green would be the initial side and the blue would be the terminal side. And vice versa, if you started with the blue and rotate up towards the green, the blue would then be the initial side and the green would be the terminal side. Now, let's look at a central angle. Now, a central angle is an angle whose vertex is the center of a circle. And one thing I'm going to try and use pretty well in this class is this particular situation where we have, an actual ability to draw a circle, which is nice. Now, here in the middle would be the center of a circle. And if I drew something that looks like this, then that angle right there would be the central angle of the circle, because it's an angle whose vertex is at the center of the circle. So here's the vertex, and here's the angle. Notice I went ahead and cut this off. I didn't make these into rays. That's perfectly fine. It's not a big deal. As for an intercepted arc, an intercepted arc is simply, in this case, that right there. So it is the arc of the circle through which the terminal side moves. In other words, if this is the initial side, then that right there going through the terminal side, all of that will include the arc on a circle. So it's just, an arc is really just thought of as the kind of like a part of a circle, just from one to the other, on the perimeter, of course. Now, let's talk about standard position, because notice that doing something like this or something like this, it can get a little bit confusing. So what we do is we define something called standard position. Now, standard position is located in a rectangular coordinate system with the vertex at the origin and the initial side on the positive x-axis. So we're going to have a coordinate system. Notice that this is the x and that's the y. What we do is we say that the vertex, I'll use blue for this, the vertex will be at the center, or the origin I should say, and the initial side will always be the x-axis. Now, what that allows us to do is it allows us to more clearly define what we mean by an angle. In this case, this would be a standard position of an angle because the initial side is here, the terminal side is whatever is not the x-axis, basically. Now, the reason that we do this is because it helps us define angles. It really does. It's very handy. Okay. Now let's talk about a degree. Now, the central angle of an arc that is 1/360th of a circle. So it's a central angle, and if you put a circle onto here, close enough. So if you put a circle onto there, it would be something that looks like this. There, and then, yeah, there's no way I'm going to be able to make that perfect. Let's just call it like that. Let's just say that that's 1 degree right there. So basically, it's 1/360th of a circle. And the reason that we say that, well, frankly, it's because whenever we first derived what all this was, we weren't using calculators, I'll put it that way. And so we chose, instead of 365, which is what it takes to go around a circle, or excuse me, go around the sun, well, technically 365.24, and then a whole bunch of decimals. I think it's like 8 blah, 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 whatever. And so instead of doing something like that, we just said, instead of 365, which doesn't really have a lot of divisors, we use 360, which has a lot more, which makes a lot of what we do a lot easier. Okay, good deal. Now then, the degree measure of an angle. Let me change that to a larger one there. So the degree measure of an angle. It is the number of degrees in the intercept arc of a circle centered at the vertex. And the degree measure is positive if the rotation is counterclockwise and negative if the rotation is clockwise. Now, why is it like that? Well, let me just kind of explain it this way. Here is a coordinate grid. The initial side is always the x-axis going that way with the vertex there. Now, with this terminal side right here, I can actually show 2 different angles. I can show an angle that looks like that. And that would be a positive angle because we started here and we went up towards the y-axis, which is the reason going up in a counterclockwise fashion. Notice that this is counterclockwise from the x-axis. Going up makes it a positive angle. Whereas I could start here and go down towards the y-axis to begin with, and this green angle right there would in fact be a negative angle. Okay, so clockwise, positive, counterclockwise, negative. Okay, now for a couple of other definitions that honestly I expect you probably already know. An acute angle is just an angle between 0 and 90 degrees. Notice that this does not include 0 or 90. An obtuse angle is an angle between 90 and 180. And again, it doesn't include 90 or 180. Now, there is an angle called a straight angle. In other words, one that would look like a line. That a line basically has an angle of 180 degrees because you can start here and go up that way or frankly down that way. So you can think of it as positive or negative 180 degrees, but it is 180 degrees in magnitude. Excellent. Also, a right angle has 90 degrees. And what about all those other angles? Well, they're called quadrantal angles. Now, a quadrantal angle is just an angle in standard position with the terminal side on an axis. In other words, 0 degrees, 90 degrees, 180, 270, 360, so on and so forth. Excellent. Now, let's look at coterminal angles. Coterminal angles are just angles that have the same terminal side separated by an integer multiple of 360 degrees. And the reason that we say that is up here, notice that this was positive whatever it was, and then this was negative whatever it was. So those two angles are coterminal because basically they look the same when you graph them. And notice that they're separated by 360 degrees because there's 360 degrees in a circle. So that's how you can tell whether or not two angles are coterminal. So there's another way of doing this. Angles alpha and beta are coterminal if and only if there is an integer k such that the measure of angle beta is equal to the measure of angle alpha plus k times 360 degrees. Basically what that's saying is that they can be off by not just 360, it could be 720, it could be, what's the next one? 1080, and so on and so forth. But not only in the positive direction, but it can go in the negative direction as well. So negative 360, negative 720, negative 1080. As long as this right here is an integer multiple, in other words, negative 0, plus or minus 1, plus or minus 2, and so on and so forth, then they will be coterminal angles. Now, degrees are actually pretty large. And so as a result, we need a way of making those a little bit smaller. The next one would be in minutes, which is 1/60th of a degree. So there are 60 minutes in a degree. And why is that? Well, you can think of that as minutes in an hour, if you will. And of course, in seconds. So you can break up the minutes into seconds as well. So it's 1/60th of a minute. So there are 60 seconds in a minute. There are also 3,600 seconds in a degree. And there are also 216,000 seconds in a circle. Good deal. Now, why do we need those? Well, frankly, think of it this way. Look up at night one time and ask yourself, how large is the moon? Not whenever it's low on the horizon, because that's kind of an optical illusion, makes it appear quite large, honestly. But wait till it's actually kind of high in the sky, and then look up and say, that's really not that large. But it's still the largest thing in the night sky, at least the largest one that's visible to the human eye. There's actually one even larger. It's called the Andromeda Galaxy. It's for me, it's actually in that direction, not at this exact moment, but it is up there, and it is quite large. But the moon itself is only about half a degree. In other words, we do it in terms of minutes. By the way, yes, the sun as well, but I don't want you to go out there and look at the sun. Sorry. I know, it's kind of crazy. I'm trying to protect your eyesight here. Anyway, there you go. So here you go. This is a whole bunch of definitions. You will get used to them, I promise. And so for now, I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.